Okay. So, one other thing, showing the distance to the points. Okay. So, okay. Well, when you do the least square methods, after you figured out what your M and your B are, then what you can do is you can say, all right, all these different components that you got, all the squares that you got, E1, E2, E sub n are vertical distances. Okay. So if we look at the last problem that we were doing, okay, so our least squares was m plus b minus 1, now squared, now plus b squared plus 2m plus b squared. This was the previous problem that we just did. Remember that we got b to equal 1/3 and m to equal 0. Okay? Okay. So if I plug 0 and 1/3 into this guy right here, 0, I don't care about that, okay? 1/3 minus 1 is negative 2/3 squared, and this is going to be 1/3 squared. And then this guy, the 2 times the m is just, that's going to be 0, and plus 1/3 squared. So E1 equals negative 2/3, E2 equals 1/3, and E3 also equals 1/3. Okay? So if we look, let me pull this up again. So what was the first point that we're using on this thing? The first point that we used on this thing was 1, 1, then 0, 0, and then 2, 0. So the distance from 1, 1, that's going to be associated with E1, and so its distance is negative 2/3. So when we plot these points, okay, so point 0, 0, okay, and then this is 0, 2, I'm sorry, 2, 0. And 1, 1, like that. And we've got this line right here, which is y, which equals 1/3. Okay, so this distance would be, where did that go? That was E3. This distance was E2, and this distance was E1, which equals negative 2/3. The other ones are kind of obvious that they're both 1/3 because they're lying on the axis, and that thing is horizontal to the axis and has a height of 1/3.